significant hurdle at the beginning of the year in chemistry is with vocabulary. Oh sure, we can handle mass, density, kelvins, and even Erlenmeyer flask without too much trouble, but throw in potassium hydrogen carbonate and we start to twitch. I hate to say it, but there's no way around a certain amount of memorizing. But memorizing itself has been shown to be a good mental exercise to keep our brain goo in good shape. The system of naming compounds in chemistry is called nomenclature. There are a few rules and a few tools you'll need at your disposal, so let's pull these together. We'll start with our tools. If you remember in the last video, we introduced the idea of ions and charge. We were able to determine the most likely charge on the ion based on its location on the periodic table. The first set of chemicals we'll be naming will be ionic compounds, salts, so the periodic table will come in handy. As we look at the periodic table, we can predict that elements in the first column will have a charge of +1. Elements in the second column will have a charge of +2. The transition metals in the middle tend to have different oxidation states. The group 3 elements, or 13 elements, will have a +3. The carbon family will have a +4. The nitrogen family will have a -3. The oxygen family a -2. And finally, the group 7A elements, the halogens, will have a -1 charge. The first thing we want to do when we go about naming a compound from its formula is to decide if the compound is ionic or molecular. Now, the idea that a compound is ionic or molecular has pretty important consequences to its properties and behavior, so we need to be able to tell the difference. The easiest way to do this is to look and see if a metal is the first element in the formula. If it is, then you have an ionic compound and we can go on to the ionic naming rules. If not, well, we'll just have to move on to molecular naming conventions. This should work pretty well for all the compounds you'll come across, with the exception of when ammonium is the first in the formula. Now let's go to the rules for naming ionic compounds. Remember, as we do this, we'll need to be able to move back and forth from name to formula and vice versa. For the most part, the compounds we'll be dealing with have only a first name and a last name. In other words, we name the cation, the positive ion, and the anion, the negative ion. So the first thing we need to do is decide, is the compound a binary one? That is, does it have only 2 elements in the formula? If there are only 2 elements, the last name is the root of the anion element name with an IDE ending. For example, if chlorine is the anion, chlor is the root, so it gets named something chloride. So that finishes the last name, but what about the first? The only thing we need to do here is decide if it's a metal with more than one oxidation state, like these. If it's not, all we need to do is give the metal its full name, like sodium or silver. If it has more than one oxidation state, we need to determine what the oxidation state is from the formula. Once we know it, we can just name the metal as before, but add the oxidation number as a Roman numeral behind it, like tin Roman numeral 4 or iron Roman numeral 3. For example, let's say we have a compound whose formula is FeCl3. Well, we don't know what the oxidation state is on iron, so we have to look at chlorine, and chlorine has an oxidation state of 1-. Since there are 3 of these, whatever I add from the iron, the sum of all these is going to be equal to 0. There's only 1 iron, and its oxidation state is yet to be determined. So if I solve this, I can see, well, I must be adding a +3 to a -3 to get 0, so X, in this case, is equal to 3. So the name becomes iron, Roman numeral 3, because that's the oxidation state, chloride. For another example, let's say we have the formula TiO2. Well, oxygen we know is typically a -2 ion. There are two of them. There's one titanium, and when I add that titanium to the two minuses of oxygen, I'll get 0. So in this case, X is equal to 4. So my name is titanium, Roman numeral 4, oxide. Okay? So what if the compound has more than 2 elements? Well, there must be a polyatomic ion in there somewhere, and the best thing you can do here is to memorize a basic set of polyatomic ions. Here is a list of the ones I recommend knowing, although your instructor may suggest others. Ammonium, NH4 1+, chlorate, ClO3 1-, nitrate, NO3 1-, acetate, C2H3O2 1-, hydroxide, OH 1-, cyanide, Cn 1-, permanganate, MnO4 1-, carbonate, CO3 2-, sulfate, SO4 2-, chromate, CrO4 2-, dichromate, Cr2O7 2-, and phosphate, PO4 3-. If you don't memorize, you'll be forever looking for your list, and it will slow you down. Okay, so now that you have a list, let's get started naming. For the first name, you'll use the same basic rules as for the binary compound. You'll just need to be aware that your cation might be ammonium. If this is the case, go ahead and name it, with the anion getting the same IDE ending as before. Otherwise, you'll need to decide again if it's a metal with multiple oxidation states and name the cation. Okay, so what if the anion is a polyatomic ion? Is it one you memorized? Well, then that's easy. Just name it. If it's not, you'll need to look it up or use these polyatomic ion rules. If it's an oxyanion, that is, a polyatomic ion containing oxygen, then you can look at how many oxygen it has relative to the one you memorized. If it's one more, then you put the prefix per on it, such as in perchlorate. If it's one less, then put the suffix ite where the ate had been. Then this would be chlorite. If it's two less oxygen, then put the prefix hypo on it and replace the ate with ite again. So this would be hypochlorite. You may also run into the case where hydrogen is tucked in with a polyatomic ion. You can then just add the word hydrogen or give a polyatomic ion the prefix bi, as in bicarbonate, or hydrogen carbonate. You should also know that the oxyanions of halogens are all the same in that the root can be interchanged to make new ions. So for example, if chlorate is ClO3 1-, then fluorate is FO3 1-. By the way, don't make the mistake of using Fl instead of F. That's just wrong. All right, with these rules in mind, we should be able to name just about any ionic compound. Now let's move on to molecular compound. These are easy, as long as they're not hydrocarbons. If you do have a hydrocarbon, a compound based predominantly on carbon and hydrogen, you'll need to skip to a different video on naming organic compounds, because these can be a bit tricky. But if you have another molecular compound, it can be a bit easier. Okay, let's assume you have a molecular compound, not a hydrocarbon. We can then ask, is it an acid? You can, for now, recognize acids as molecular compounds which have an ionizable hydrogen. That is, it usually starts with hydrogen in the formula. If it's not an acid, Naming it is super simple. Just use the prefixes to represent the subscripts. For example, this would be dinitrogen tetraoxide. And this would be carbon dioxide. Remember, you won't use mono for the first element, so saying monocarbon dioxide would be wrong. Okay, but what if we do have an acid? Well, these are not that hard either. If the acid is binary, that is, it's hydrogen and one other element, it gets the name hydro, then the root of the second element, then ic, acid. So H2S would become hydrosulfuric acid, and HCl would be hydrochloric acid. If the acid has a polyatomic ion in it, you'll need to identify the name of the ion, and if the name ends with ATE, like hydrogen sulfate or hydrogen perchlorate, you'll need to change the ate to ic. Remember, if you ate acid, it would be icky. The acid name then becomes the anion root plus ic acid. So in our examples, hydrogen sulfate becomes sulfuric acid, and hydrogen perchlorate becomes perchloric acid. If the acid anion ends with ITE, like nitrite or hypofluorite, you will change the ITE to an OUS, and the name becomes the anion root plus US acid. So hydrogen nitrite becomes nitrous acid, and the hydrogen hypofluorite becomes hypofluorous acid. So, that's it. With the rules covered in this video, you should be able to understand the names and be able to write the names for most of the compounds you've come across in this course. To practice your understanding, I've given you a list of formulas. Press pause and see if you can write the name before reviewing the answers. Now I've given you a list of names. See if you can write the formulas. Press pause and write down your answers before you check them. I hope you were successful, but if not, just a little time and practice will have you writing formulas and names like a pro. In the next video, we'll start putting these formulas to use in chemical equations.
What's your name? I have seen you before. What's your name? May I walk you to your door? It's so hard to find a personality